Welcome to Brain Vision.
For this question, we have to choose as the reference frame the following. Everything that is pointing to the left is pointing to the negative direction, and everything that is pointing to the right is pointing to the positive direction. This is because the problem says that the force is minus 267. This minus sign indicates the direction of this force. Therefore, the force must be pointing to the negative direction of our reference frame. So this is why we have to make this choice. Okay, now proceed to the question. So if the refrigerator does not move, its acceleration is equals to 0. Then Newton's second law tells us the following. The net force is equals to 0. But the net force is composed of two forces. The frictional force, which is positive, minus the pushing force, which is 267 newtons, to the negative direction. So this is why I put a minus sign there. And this is equals to 0. Therefore, in the situation proposed by the first item, the frictional force is equals to 267 newtons. Now, for the second item, we have to calculate what is the largest possible pushing force that one can apply to the refrigerator without moving it. So the maximum frictional force that can be produced by the static frictional coefficient is given by the following. So the maximum frictional force is equals to the static frictional coefficient times the normal force. And the normal force is the force that the floor is exerting on the refrigerator, which is this force. Now, how can we calculate the normal force in this situation? You have to note the following. In the vertical axis, the refrigerator isn't moving, so it can't fall below the ground because the ground is holding it there, and it also won't start flying out of nowhere. It will just stay on the floor as it is. Therefore, the normal force is equal to the weight force. Then we can use this in this equation to get that the frictional force is equals to the static frictional coefficient times the weight force that acts on the refrigerator. And the weight force is given by the mass of the refrigerator times the acceleration of gravity near the surface of the Earth. We know that this acceleration of gravity is approximately 9.8 meters per second squared. Therefore, the frictional force is equals to 0.65 times 57 times 9.8. And this gives us a maximum frictional force of approximately 360 newtons. So this is the maximum pushing force that can be exerted without moving the refrigerator. If we apply a force of 361 newtons, the refrigerator should start to move.